In this tutorial, we're going to learn how to name alkanes and cycloalkanes. First of all, hydrocarbons consist of carbon and hydrogen atoms, and we name saturated hydrocarbons or alkanes hydrocarbons that are lacking any pi bond, meaning that those atoms are going to have only sp3 orbitals. We will now follow a systematic method to name those compounds, as this was established by IUPAC. And the first rule that we're going to learn says that at any given compound, we have to select the highest number of carbon atoms, or alternatively, meaning that we have to find the longest chain. And this chain will be named as the parent chain. Let's find out now in the compound we have the number of atoms. If we start from the left, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. So here we're going to have 9 carbons, while if we start from the right, we're going to have 1, 2, 3, 4, 5, 6, 7, 8 carbons. So in this case, we see that the one in green is going to be the parent chain, and the rest will be substituents, which means this one, and that one will be substituents. How we name this parent chain? Because it has 9 carbons, the name will be non, and because it's an alkane, the suffix will be ane, as we see in the table that we have. Here we can see that 9 carbons have the name non and get the suffix ane if we talk about alkanes. Now let's find out the parent chain in this compound. If we start from the left, we have 1, 2, 3, 4, 5, 6, 7, 8 carbons. Well, if we start from the right, we're gonna have 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. So in this compound, we see that the parent chain is the one in green, and that one will be a substituent. How we name now this compound? Since it has 9 carbons, the name will be non, and again it's an alkane, so the suffix will be ane, so this one will be also a non-ane. Let's see now a more complex case in which we're gonna have the same number of carbons. So in this case, let's measure it first. We see that here we can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this case, we're going to have 10 carbons. Well, if we measure the number of carbons but from the opposite direction, we see that here we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons. We see that also here we're going to have again 10 carbons. So in that case, let's find out the substituents. So this one will be substituent, this one will be a substituent, and then we're going to have this substituent and this substituent. So we see that the one in red we're going to have 4 substituents, while in the one in green we're only going to have 2 substituents. And as far as we have the same number of parent chain, the same number of carbons, the parent chain name will be a decane, because we have 10 carbons and we use the suffix ane for alkanes. Let's now in the case of cyclic structure. So the rule here says that if the cyclic structure will have higher number of carbons than the substituents, then that one will be the parent chain. So if we measure here number of carbons, here we're going to have 1, 2, 3, 4, 5, 6, while that one has only 2 carbons, and in this case this is going to be a substituent. While if we go to the other compound, we see that if we measure the number of carbons will be 1, 2, 3, 4, 5, 6, and the cyclic structure is going to have only 3 carbons. In that case, the one in green, the cyclic compound, will be the substituents, and the one in red will be the parent chain. Let's see now how we name the parent chain. In the left case, in the left one, we're going to have 6 carbons in a cyclic structure, so this is going to be a cyclohexane, and this is the name of the parent chain, while on the right the name of the parent chain will be hexane. So it's very important to learn and know how to name the parent chain, and in the next tutorial we're going to learn how to name the substituents.